Hello everyone, we will continue with the course evaluation of textile material. In last classes we have discussed the characteristics of fiber, few characteristics like length, maturity, fineness. Today we are going to start the evaluation of yarn characteristics. We will start with the most important characteristic, which is linear density of yarn. Actually, in textile yarn we would like to know the diameter of yarn or cross section, same as in the fiber case. We have seen that in fiber it is very difficult to measure the diameter of fiber. So, indirectly we measure the fineness in terms of linear density. So, in case of yarn also it is very difficult to measure the diameter or cross sectional area. This is mainly due to the fact that the thickness or diameter of a yarn is one of the most fundamental properties, but it is very difficult to measure because it is not possible to measure the diameter of yarn in any meaningful way, because it is very difficult. For say staple yarn, as it is compressible in nature and the diameter also it is not uniform throughout the cross section, throughout the length. So, it is very difficult to measure the diameter. The change in diameter is mainly due to twist applied on the yarn. If we consider the distribution of fibers in the cross sections are same, even the most uniform staple yarn will have variation in diameter. This picture will show that the diameter of yarn at different places are different due to inclined the helix angle of the fiber. So, this is due to that at different point also the tacking coefficient of yarn also changes, and that results the variation in diameter. So, it is very difficult to measure the diameter of yarn, particularly the staple yarn. That is why the indirect method of measuring the fineness is the linear density. So, a system of denoting the fineness of yarn by weighing a known length of yarn, it has been developed. So, linear density is indirectly showing the fineness of yarn. So, this quantity is known as the linear density. It can be measured with a high degree of accuracy if the sufficient length of yarn is used. So, the linear density is extremely important for knowing the length of the yarn for a known quantity, known the mass of the yarn. So, this is used in many applications. Suppose if we know the linear for a known linear density of yarn, if we have a cone of yarn, we can simply take the mass of the yarn. We can take the actual mass of the yarn, and from there if we know the linear density, we can calculate the actual length of the yarn. This is used in many applications like in warping. In warping, if we know that if that the count of yarn and the mass of the package, so we can predict, we can calculate actually that what will be the actual length of the warper's beam. So, in that way the total length is it needs to be calculated, and also if in the other way, if we know the length of the yarn, we can calculate the mass of the yarn by knowing the linear density. So, there are two systems of linear density measurement. The systems are, one is the direct system and next one is the indirect system of measurement. In the direct system, which is very convenient system, that is the direct system of denoting the linear density is based on the measuring the mass of yarn per unit length. Okay. So, mass per unit length of yarn is the direct system of measurement, and here the length unit is fixed. So, if we know for a particular fixed length, we calculate the mass. So, directly we can measure by measuring the mass. We take the fixed length, then we measure the mass, that will directly give us the linear density in direct system. That means, if a particular x length of yarn, one yarn gives the lower mass, that means that will have, so that it will have the lower direct system lower count. Okay. So, finer the yarn, lower is the yarn number. So, takes that in the direct system, the whatever the number, whatever the systems are there, the lower value means the finer yarn and higher value it is a coarser yarn. So, there are different systems of measurement in direct systems. These are the Tex system. Here unit of mass is in gram and the unit length is 1000 meter. So, 1000 meters, say 1 kilometer. So, in 1 kilometer yarn, we take the length of the yarn 1 kilometer, and whatever mass is coming, that will be directly termed as Tex. Suppose if we take 1 kilometer yarn, and if it is its mass is 15 gram, then that will be same, it is a 15 Tex. Similarly, if we take 1 kilometer yarn, if it is a thicker yarn, then mass will be say more than 15 gram, say mass is 30 gram. So, in that case, so Tex will be 30. So, coarser yarn or thicker yarn will have higher Tex value. Similarly, the denier, it is again the unit of mass is in gram, but the length is 9000 meter, 9 kilometer. So, that means the 9 kilometer yarn if we take, and if its mass is say 15 gram, that means it will be 15 denier. So, earlier we have given example, the 1 kilometer yarn we are taking, its mass is say 15 gram. So, it is a 15 Tex. Now, we are taking say 9 kilometer yarn, the mass remains same, say 15 gram. So, it is a 15 denier. So, the denier is it is a for 15 denier yarn, 15 denier yarn and 15 Tex yarn. So, 15 denier yarn is finer by 9 times. So, that way we can have different relationships. I will discuss the relationships between different count system. Decitex is similar way, it is a mass in gram of 10,000 meter, 10 kilometer yarn. So, it is little bit finer than denier. So, that is why these systems they are used for different types of material, like Tex system normally used for staple yarn, okay, where the number is little bit coarser, and denier or Decitex normally we use for filament yarn. It may be multifilament yarn or monofilament yarn. These are the conventions, but we can use the other way also. The text we can use for the filament yarn also. Okay. Let us see, one text is 10 decitex yarn. So, that is what we have discussed, because one text in text system the length unit is 1 kilometer and in decitex length unit is say 10 kilometer. That is why it is 1:10 ratio. The general formula for direct system is, if we know the length of the yarn and if we know the mass in gram mass of the yarn for that particular length. So, we can calculate the text value or any value in direct system. So, n is the yarn, this is the general formula, n is the yarn, the number, the yarn number, so or count system. So, n is the yarn number in direct system, L the length of the sample, that is if we take the sample, it need not be always that as per the standard. So, in text system if we want to calculate text system, the standard length is 1 kilometer. We need not always take 1 kilometer yarn, we can take say few meter yarn or 100 meter yarn or like that. So, any yarn. So, that is the length of the sample, and then what we do, after taking that known length we take the mass. So, that the mass, that is m, capital M, it denotes the mass of the sample at the official regain in the unit system. That means, if it is in gram, then we have to take mass in gram system. So, and it says that is official regain. So, that regain, moisture regain has to be perfect, otherwise there will be difference in yarn number. So, as per the, and that is why to get the official regain we have to condition the material for say 24 hours, but before we measure the count, and that is why we have to allow the yarn to settle, to actually to get that regain. Okay. And small l is the unit length of the system. So, for text system the unit length is 1000 meter. So, L for text system, small l for text system, it will be 1000 meter. So, using this parameters we can calculate the yarn number using the simple formula, capital M multiplied by small l divided by capital L. Capital M is the mass of the material sample and capital L is the length of the sample. So, and let us take one example, say mass, we want to know the text value of yarn, and for a mass of 25 gram and length of the yarn is 2.5 kilometer. So, mass of 2500 meter yarn is 25 gram. What is the text value? So, it is a very simple, using the formula text system mass in gram of 1000 meter. So, using that formula the mass of the yarn M is 25 gram, small l is 1000 meter and capital is our sample length is 2500 meter. So, using this simple formula we can calculate the text value of the yarn. So, we can also, if we want to calculate the denier, the main difference is that the small length. In denier the small length it will be say 9000 meter. So, if we use in place of 1000 meter, if we use 9000 meter, then it will be 90 denier. So, that way we can calculate, if we know the mass of yarn for a particular length. So, we can calculate the yarn number. Now, coming to the indirect system. So, indirect system is little bit complex, it is not the direct. So, but this system is a traditional system. So, this is the traditional system of ion linear density measurement. So, earlier nowadays we also follow this indirect system, but in as per ISO this the TEX is the standard system of measurement. So, the indirect system is based upon the length per unit mass. So, in direct system mass per unit length, if we measure the length then we can take directly the mass, but here the length per unit mass. So, mass is fixed and for that mass what is the length. So, here it is a little bit awkward it is looking, because if we know the mass, okay, we have to then calculate we have to get the actual length of the yarn. Oh, that is why it is indirect system, but in traditionally it was used. The indirect system is based upon the length per unit mass of the yarn and usually known as count. So, this count is a term, it is a normally it is a people ask that why is it called count, why the linear density we call as count. Okay. It is based on fixed mass system, as it is a length per unit mass. So, mass is fixed. Now, let us take one example, okay, for cotton yarn, because the count term came from normally it is a cotton yarn. In earlier days during trading, people that the unit of mass was used as pound. Okay. Pound was the unit of mass and the length of yarn was actually 840 yards. It is a hank of yarn, it is a skein of yarn. So, what they used to do? They used to make one li. Okay. So, that one li is length is 120 yard. Okay. 120 yard li, such 7 lis are there. So, 7 lis of 120 yard will be 840 yard. So, they used to make one bundle of 840 yards. Okay. They are making one bundle of 840 yards, and these bundles and there was a weighing balance. They used to put the bundle, that bundle, one bundle they are putting, okay, they are getting, and there they keep on putting the bundle till the mass becomes 1 pound. They have to actually they have to make a bundle of 1 pound. Okay. Now, they are trying to put one hank of 840 yard, it is not 1 pound, then 2 hanks, 3 hanks, and they keep on counting. They keep on counting 1 hank, 2 hanks, 3 hanks, like that, keep on counting, and suppose it is a 30 count. So, after putting 30 such hank of 840 yard, it has become 1 pound. So, then they are packing as 1 pound bundle, 1 pound bundle of say in that bundle there are 30 such hanks are there. That means that will have 30's count. So, they counted the number 30. Now, suppose it is a finer yarn, again they are putting hanks of 840 yards. If it is finer yarn, then the number of such hank will be they will count, they will again keep on counting, they will count the number and that will be more than say 30. So, suppose it is a 50, it is after counting they count it is there are 50 such hanks are there. So, that hang then they are making bundle of 1 pound, in that bundle there will be 50 such hanks. So, they have counted the number as 50. So, that is how the term count came, and this 50 count. So, here it is the system in the indirect system, the higher the count number, the finer will be the yarn. So, that is why, so the in indirect system it is the system of counting. So, count term came from there, and nowadays we normally use that it is a English count or any it is a count, and people used to say that is a text count. The count has become term for linear density, but actually count initially was used for indirect system. So, finer the yarn, higher the count number, and also it is not, people used to say yarn number. What is the yarn number? The same way the number came. Okay, number, how many such bundles are there, how many such hanks are there in 1 pound. Okay. So, this English system, this English count NE is also still used in particularly in cotton yarn system. In it is also called cotton count. Okay. So, in indirect system there are other methods of indirect system measurement, the Oersted count NW. Here number of hanks of 560 yards, in 560 yards in 1 pound. So, for Oersted system we do not make a hank of 840 yards, here we used to make hank of 560 yards, because the Oersted yarns are little bit bulky in nature. So, if we actually make a hank of 840 yards, then it will be little bit bulky, heavy, bulky and the voluminous. That is why it has the hank system, here hank is 560 yards, and that is why new counting system NW has been evolved. Cotton system, as we have discussed, 840 yards. Another system is metric count. Metric count, where we use these terms yard and pound in terms of kilometer and kilogram, that is in metric system. So, number of kilometer length per kilogram. Here what we do, we take the yarn of say 1 kilometer each. So, such how many 1 kilometer yarns will be there in 1 kilogram, that will be the number. Now, we will see that there we can convert, we can actually transfer from one system to another system, that we will discuss. The general formula for indirect system is again N is the yarn number or count for that system, L is the length of the sample. Suppose we have taken a certain length, okay, for testing, okay, that is the length of the yarn, and the mass of that yarn. Suppose it is a 120 yards we have taken only, we have not taken that whole length, we have taken only 120 yards or any length, and mass of the yarn of the at the official regain in the unit of that system. So, in the same unit we have to take, and L is the unit length of this system, okay. That is the system, and M is the unit mass of the system, because in direct system we have not used the unit mass M, because in most of the systems we have seen it is a gram, 1 gram per something, okay, number of gram. So, here it is a M is the unit of system, and this is the general formula M, this M unit of mass of the system, L is the actual length of the sample, actual mass of the sample, unit of length of the sample. Okay. Now, let us take one example here, mass of 120 yards of yarn Li is 3 gram. So, we have taken mass of yarn, we have taken made a Li, and then we have taken mass. So, it is a 3 gram. What is the cotton count of the yarn? So, cotton count Ne is the number of hanks of 840 yards long in 1 pound, that we have discussed. Now, cotton count is using this formula here, M is the mass of the that system. What is which one? What is this? It is 1 pound, and in 1 pound, and we are trying to convert into same unit of mass. So, here the mass is the mass of sample is in 3 grams. So, we can convert this 1 pound to gram. So, 453.6, that is the gram, and 120 yard, we are keeping the length of it is 1 yard, because it is the same unit as the count system. So, 120 yard, and this the mass of the sample, it is a capital M is the 3, and length unit is 840 yards. So, in that way we can calculate the count of yarn in English count. Okay. So, English count is 21.6. So, what happened here? We can see here this mass M, it is always constant 453.6, it is constant, and this L length, it is constant. If we take the yarn in a sample, if we take the mass length of the yarn in length of the yarn in yard unit, okay, and mass of the yarn in gram unit, if we take that one, then we can simply eliminate this term. We can actually use a constant term, that constant is 0.54, that is a 453.6 by 840. So, that means directly we can use 0.54 multiplied by length in yard divided by mass in gram. So, in that case one care has to be taken, we should always take the yarn in yard unit and length in gram, because yard unit in wrap reel normally we get yarn length in yard unit. Also in mass unit, that meter also it is available. In that case we have to change this factor. Okay. If it is in mass unit, so mass, so if it is in meter unit, then we have to change this factor a little bit. So, in that way directly we can measure the yarn count. Now, let us see how to convert one count system to another count system. This we can calculate, but this table will give us direct count conversion system. Okay. Now, this table we can just see from text to text, it is okay, directly it is a text value, and if you want to take the text value, so text to decitext. Okay. Text to decitext. So, suppose a yarn, we have one yarn of say 10 texts, 10 text yarn. So, what will be the decitext? So, 10 multiplied by 10, it will be 100 decitext. So, if we want to know the denier of the yarn, that means you have to multiply by 9. So, 90 denier of yarn. Suppose we have the value decitext value. So, 100 decitext. 100 decitext, what will be the text value? Text value will be say 100 by 10. So, 10 text value. 100 decitext, what will be the denier? It will be 90 denier. Okay. Similarly, suppose we have say 18 denier yarn, 18 denier fiber. Okay. What will be the text? 18 by 9. So, that will be 2 texts. So, in that way we can convert. Similarly, for metric count, suppose we have 100 Nm yarn, 100 metric count yarn. What will be the text value? So, it will be 1000 divided by 100. So, it will be take 10 texts, and then it will be 100 decitext, and it will be 90 denier. So, in that way we can simply convert, and if we want to convert the English count to the English count to the other counts, suppose if it is a 10 English count, then text will be 591 approximately divided by any 591 559.6 text. So, in this way we can convert all the count systems. Now, this 591. How this 591 came? It is a very simple calculation. We can calculate, we can just simply convert the mass and length units and we will get this value. Similarly, it is a conversion, another conversion system is that text metric count, text to metric count. If we know the text, then you can calculate the metric count. Earlier it was text to other count. So, text decitext here the metric count and English count. So, we can convert from one count to another count. Okay. So, if we know the say English count, we can get the metric count. So, in this way we can calculate. Okay. Now, the use of this counting system is that, as I have mentioned, we need to know precisely the actual length of material, actual length of yarn in a consignment. So, if the yarns are in the package, so length measurement is not that easy, we cannot unwind the yarn and measure. So, in that way the counting system helps. Suppose a polyester yarn, the polyester filament yarn in a package, the package mass is say 2 kg mass and its denier is known to be 180 denier. So, for my production, say knitting or weaving or any other process, for a particular requirement I need to know the what is the length available, how much length is available here. So, this is the say one example, I have say 2 kg of 180 denier polyester filament. So, I need to know the length, so that I can predict whether it will be it will actually serve my purpose or not, it will be sufficient or not. Okay. Now, denier is known here and mass of 9000 meter of polyester yarn is 180 gram. That is, if it is 180 denier, that means 9000 meter of filament will have 180 gram, and then simply we can calculate the length. So, the length of 2 kg yarn will be 9000 is the, that is the 180 for 180 gram 9000. So, 9000 by 180, that is for 1 gram, divided multiplied by say 1000, this 1000 it is for 1 kg yarn, and so this much kg yarn, and for 2 kg it is multiplied by 2. So, this total quantity 9000 multiplied by 2 by 1000 by 180 multiplied by 1000 by 180, this term comes out to be in meter. So, if you want in terms of kilometer, you again divided by 1000. So, that is how we can calculate the total length of yarn, and if we know the length of yarn, then we can actually plan our production. Okay. So, but our suppose our production line needs a yarn of say 150 kg. So, then in that case I can tell 2 kg yarn will not work. So, in that way we can 150 kilometer yarn my production line, the product whatever say woven fabric or knitted fabric. So, depending on the I have calculated, in that case suppose my requirement is 110 kilometer yarn. Okay. In that case if I take 2 kg yarn, then it will not work. So, in that case I can precisely calculate how much weight, how much mass is required, what is the quantity of yarn is required. Okay. So, that is the solution. And next is that another similar problem, length of 20 tex polyester cotton yarn in kilometer of 6 kg cone will be equal. So, I have a 6 kg cone. So, I need to know what is the length. Okay. So, 20 tex is there. So, mass of 1000 meter yarn is 20 gram. In the similar way we can calculate. So, 1 gram yarn will have length of 50 meters. Okay. So, 6 kg iron we will have 6 into 1000 into 50, that is a this much 6 kg. So, this much meter iron, and we can calculate the length, it is a 300 kilometer length. So, this way we can calculate the length of yarn from known mass, or from the length, if we know the length we can calculate the what will be the mass. So, this mass also, this length, this system also helps in other way. Suppose my production line needs a certain length of yarn, and we can calculate the how much quantity, because we cannot order the yarn, we cannot purchase yarn in terms of length, but our planning department, suppose after calculation they say for warp we need this much length of yarn. From there, if we know the yarn count, then we can calculate the how much quantity of yarn required. So, this counting system helps in both the ways. Now, try to see how to calculate the count of folded yarn. So, folding and plying is very common practice in textile industry, because in most of the cases we need the folded yarn. Okay. That is, and we must know how to express the, how to calculate the count of folded yarn. And if we know the, because folded yarn count we can also measure by measuring the directly count system, but if we know the individual yarn count, so in that case we can predict what will be the folded yarn count. So, the count of individual threads, that is singles, that have been plied together to form the final yarn is called folding count. So, that means if we twist, if we fold a number of single yarn, and then if we measure the count of plied yarn, then that will be called as folding count. If there is only one in the ply, then the yarn itself is often referred as singles of yarn. So, that means single count, another is folding count. However, depending on the count system being applied, so whether it is a direct system or indirect system, or if it is that direct system or indirect system, we can calculate the resultant count, but different counting system like cotton counting system, worsted counting system, or spun silk counting system, the folding number, how they appear, it gets changed. The folding number appear differently in the yarn count system, and here we should be very careful in which counting system it is being expressed, like using any of the cotton, woolen or worsted system. So, if we use the cotton system, woolen system or worsted system, the twofold 30s count, 30 any cotton yarn, we can write as 230. Okay. So, 230 means it is a single yarn count is 30 and it is plied in 2 times. Okay. 2 threads are there. Similarly, so 320s means 20 single count yarn is twisted with the 3 ply. Okay. 3 plies of yarn, 3 fold of yarns are there, where first digit signifies the folding number. So, 230s means the 2 is the number which is the folding number, and second digit is the count of each system. Now, the problem here is that this system, it says that all the individual yarn count should be exactly same. Here the same yarn is twisted. if we twist say 30s count and 40s count, in that case we cannot express in this way 230s. So, this if it is in cotton system of expression, 230s means 230 count yarn is being twisted. So, you will have certain resultant count, but this problem is actually eliminated in another way, which is known as spun silk system. Just to actually avoid any confusion, so spun silk system here, say a twofold of 30s cotton count yarn would be written as 215, because the officially the count of spun silk is the total yarn count. Okay. That is, this is the total yarn count 15 count. Okay. That means twofold of cotton yarn. So, if we will see in the next section that if we twist 2 30s count yarn, the resultant will be 30 any yarn, the resultant count will be 15. So, here in this system first digit shows the number of ply and the second digit shows the resultant count. So, this counting system, it is spun silk system, we can use in various actually wide applications are there, where a number of yarns of different count or different nature can be twisted and we can express. Okay, that we will discuss. With the folding number placed in front and the total digit, that resultant count in after that. Okay. Here folding number is 2. The direct system is almost always simpler. So, it is very simple and generally is to be preferred. Now, in SI system, it is a text is regarded as the linear density expression of linear density in of yarn. Okay. It is a text, we do not normally use, we do not use any or any other method in the SI system. So, if we have yarn linear density in English system, NE or NM metric system, in SI system we have to always convert it to in terms of text, that is the SI system, internationally accepted system. Okay. Now, try to see the count of folded yarn. It is a say resultant count in the indirect system. Resultant count is NR. So, NR means it is a length of yarn for a particular mass. Okay. That is the indirect system NR. So, suppose in the component yarns there are n number of components, N1, N2, N3, N4 are the count of individual components. Okay. So, these are the individual components, first component N1, second component N2 in this way. Now, we want to know what will be the, if we actually fold together all these yarns or ply it together and if we twist together, we would like to know the resultant count, resultant any of the yarn, English system or indirect, any indirect system of the yarn. Here the assumption is that during twisting or folding there is no change in actual length of the yarn, that assumption is there, but if at all the contraction is known, then we can actually calculate the actual count by actual correcting the factor by using correction factor. So, the resultant count is the reciprocal of the addition of the reciprocal of the count. So, 1 by NR equal to 1 by N1 plus 1 by N2 plus 1 by N3 plus 1 by. So, in this way directly simply we can use, we can actually derive this formula also, but direct simply it is a simple derivation, we can use this formula of count of folded yarn. In direct system it is a simple one, because it is a mass per unit length. Now, if we fold say 2 yarns, the length is fixed, mass will be simply added. So, that means in direct system the count of folded yarn is simple addition of the individual count. So, N R D, okay, that is the resultant count in direct system, so, individual component 1 D, 2 D, N 2 D, N 3 D like this. Okay. So, this is the simple addition. Okay. Suppose one yarn of certain length has got say mass of x, another yarn of same length has got mass of y, then the resultant yarn of same length will have mass of x plus y. In the same way it is simply added. Okay. Now, let us try to solve few problems. Okay. Some problem. What is the tex count of 350s any of 3 ply yarn? Okay. 350s any yarn. So, that is the folded yarns count we want to measure. So, this is the English system of expression, that means the individual yarn count is 50 and it is plied 3 times, okay, 3 ply. So, resultant count in English system we have to calculate. So, that individual yarn count is 50. So, resultant yarn count using the earlier formula of folded yarn 1 by N 1 plus 1 by N 2 plus 1 by N 3. So, this is the equal to 1 by N E R resultant count, okay, of in English system, and the resultant count will be 50 divided by 3, that is 16.66, and using the earlier table we can get the resultant count in tex system. Here it is asked the count to be in tex system. So, we know the N T multiplied by N E R equal to 590.1 approximately, it is 1/4. So, in that case N E is known, N E R is known. So, we can calculate N T. So, 590.4 divided by 16.6 is it is coming out to be 35.42 N T. So, for 350s yarn the English count yarn is the tex value is 35.42. Okay. So, in that way we can always convert. This is the answer. Now, next problem, it is a, that means what is the count of a multi-filament yarn in tex with 36 filaments in that multi-filament monofilaments of 3 denier monofilaments. Okay. So, so each monofilament has got 3 denier, such 36 monofilaments are there to form that multifilament. Okay. So, that, so here the count system, linear density system is in direct system, and such 36 filaments are there, that means the it will be 3 denier will be added 36 times. So, 30 such 30. So, it will the resultant denier of the multifilament is N D R. Okay. This is it is a count number in denier of resultant yarn. So, N D R is equal to N 1 plus N 2 plus N 3 up to N 36, and all the counts are same 33 counts. So, it is multiplied by 36 means 108 denier is the denier of the multifilament, and we can simply convert this denier to tex by dividing with 9. So, it is coming out to be 12 tex. Okay. So, this yarn it is converted to 12 tex. Although these are very simple, but the applications are wide. So, we can always convert this term, because people would like to know in terms of text just for comparison. We may get the yarns or filaments in different count system, but people always would like to know in standard system just for comparison. Okay. This is the 12th count. Another system is that this problem, this is the very practical problem and which we actually face in day to day industry application. So, it is not that in multi folded yarn, the idea is not always to get a thicker yarn or to get some even yarn or a stronger yarn. Sometime we try to ply to get a certain blend proportion or certain special characteristics. We sometimes ply the filament with the staple yarn, polyester with wool, polyester filament with cotton filament, cotton staple yarn, like that. So, cotton yarn with polyester filament or nylon, this type of combinations are required in many applications, particularly in technical applications. So, we must know how to calculate the resultant count. So, what is the resultant count of 3 ply yarn in tex, twisted with 50 Nm worsted yarn? One component is worsted yarn of 50 Nm, next component is 100 denier polyester filament, and then 60 Ne cotton yarn. So, that is the combination, this 3 polyester, cotton, wool or wool blend, whatever. So, this is the combination. Now, we would like to know what is the resultant count in tex. So, here the resultant count in tex is NTR. Tex. First, here we have to first step is that we have to convert individual count, different count to a particular single count system. Here what we have done? We have done to a count system which is required, tex system. It is not always necessary to convert into the required system, we can convert into any other system and finally, we can convert. The resultant tex count is NTR. So, for wool the count was it was 50 Nm. From the earlier table, conversion table, we have seen the tex is tex and Nm conversion was 1000. So, 1000 by 50 it has become 20, 20 tex is wool yarn. Similarly, for polyester filament it is actually it is given in denier term. So, the denier was 100 denier, 100 denier polyester. So, the in tex the polyester filament tex was 100 by 9. So, it has become 11.11, 11.11. Okay. So, that is the tex of polyester filament. Now, a third component is that the cotton, it is a 60 Ne cotton yarn. Now, in third component again we have converted the third component in tex system. So, 590.1 divided by 60 it has become 9.83. Now, we have got 3 different yarns of same count. Okay. First we have to convert it to in the same count, then we are trying to apply the formula of plying, and here again assumption is that there is no contraction. Okay. So, then we are applying the formula of folding. So, the folding formula for direct system, as we have converted into direct system. So, it is it is always good idea to convert to any of the direct systems. So, that will help us in just simply adding. So, 20 takes plus 11.11 takes by plus 9.83 takes. So, if we add together, it is coming out to be 40.94 takes. So, that is the required count. Okay. So, this type of problem is always we face in the industry. So, we can simply calculate. Okay. This is the answer. Now, in the next segment we will start the measurement of ion linear density. Till then, bye. Thank you.